Welcome to the Inside Digital Transformation Podcast. Inside Digital Transformation explores how organizations of every size and shape are using technology today to survive and thrive in the face of relentless change. If you are a business or technology leader charged with making the most of digital transformation in your organization, then this podcast is for you. And now here's your host, Alan Bernard, a technology journalist, editor, and copywriter who has been covering the intersection of business and technology for over 2 decades.
Hi everyone, thanks for tuning in. Today I'm speaking with Forrester analyst Rowan Curran about the hottest topic in tech today, which is the AI chatbot, ChatGPT. We're going to get into what it is, what it isn't, which is sentient or intelligent, and we're going to explore the outsized impact it is about to have on how we all interact with technology, both at work and in our daily lives. So Rowan, thanks for being here.
Thanks for having me.
Yeah, absolutely. So, today we're talking about ChatGPT, but more to the point, I don't want to focus strictly on that. I want to think about generative AI and kind of the Pandora's box that ChatGPT has opened for everybody, including myself. When I came across ChatGPT, I was really floored, and I was late to the party. I didn't see it until about 3 weeks ago. It really, I think, is a true bit of a game changer, right? Paradigm shift and how people think about AI, think about what it's capable of. It has really opened that door to people's imaginations as much as anything of what's possible, right? With
Absolutely.
These technologies. So I want to explore that, right? But I think really we have to start with what is ChatGPT, right? And in layman's terms, obviously. And so even though it's fairly well explained in a lot of different places, right? We still should cover some of that ground. So why don't we go there? Let's start. What is it? And then we'll just go from there.
Yeah, absolutely. So ChatGPT is based upon a large language model. And a large language model is a class of models that essentially uses a very, very large underlying set of data that is combined as a broad set of data that involves, sorry, go ahead.
Well, no. So I was going to say that's everybody refers to that as parameters, right?
So when we're talking about parameters are basically what has been derived from that data set that the model is actually using to relate different topics to each other. So metaphorically, you could think about parameters being similar to neurons. So it's not a one-to-one relationship, but if you think about human biological neurons, the more neurons you have involved in a task, the greater kind of the emergent capability. And it's similar when you look at these large language models. The first large language models that came out in 2018, the first paper that was published around these things came out in 2017. The first large language model itself was published in 2018. So these are still relatively new.
Yeah, that is new.
That had, I believe it was just over 100 million, maybe 117 million parameters. I could be wrong. It could be a couple hundred million.
I just saw on my research, it was 100 million. So,
okay. So, and now we have, the 3.5 series from OpenAI has, billions and billions of parameters. And, we are quickly on the road to getting to, trillions of parameters. And it's a very real possibility, though, there may be some bumps along the way to that. But, when we're looking at these models, overall, the thing to remember about them is basically what they're doing is they're taking this vast underlying supply of knowledge and then relating all of that knowledge to itself. So similar to the way that, a person, takes in experiences over the course of their life, they learn things. These models relate a huge set of data to each other and then will try to respond to prompts that are submitted to them. Now, the way that these models respond to prompts, so say a question that you're submitting to ChatGPT, is that they are trying to guess what the next best word in that sentence would be. So while that can result in very accurate and very human-like responses, ultimately, this is what also leads it to, doing things like creating coherent nonsense and generating hallucinations that many of us have seen in the media.
And a hallucination being just some made up dream state answer that really has no basis in reality, right?
Yes, and one of the problems with these things is that they're so confidently communicated that it's can be very hard to identify them if you don't actually know what the underlying claim is. So, the large language model is the fundamental component of ChatGPT, as well as, Lambda from Google, and, there's a number of others out there.
Which is the foundation of BART, I think is there.
It may be. It is unclear whether that is. They've claimed it is. There may be some other version of the model. It's unclear what the exact pipeline is. But then there's, Cohere and A21 and a few other folks that are building their own foundation models and making them available. NVIDIA has Megatron. There's a number of them out there. But when we're looking at an application like ChatGPT, the large language model is just the first piece. Then additionally, there's a couple other layers wrapped around it. One of those layers is what is called reinforcement from human feedback. And essentially, that is a way of refining the model and improving its answers through telling it how it's doing in responding to queries. So once the model is trained, you can kind of think of it as a small child who, has never actually had conversations with folks, but knows a lot of things. And then you have a bunch of conversations with it, and it learns about how humans talk to each other. And ChatGPT, has had millions of people having, probably hundreds of millions of conversations with it. So that reinforcement layer for ChatGPT is quite strong.
So it's learning from everything I type in. Every conversation I have with it, is it learning from that?
It is learning, yes. And then also, the thumbs up and the thumbs down that you can give on the answers, that is also providing feedback to it as to whether that answer was, high quality or not.
But before this model was launched, they were using actual humans to do that. Right, to refine the model before they launched it, people were actually sitting down and interacting with.
Yes, correct. Yeah. So one of the things about all these models is, in addition to doing that kind of baseline layer of training, you do have to the unsupervised training where you just give all the data sets to it. You then have to do all this conversation training on top of it. And, one of the things that OpenAI has gotten from its release of ChatGPT is basically, the biggest crowdsourced engine for doing this reinforcement learning that, anyone could have ever imagined. And especially, the swath of humanity that they're probably getting access to in terms of the way that people ask questions and respond to these things is much more diverse than I can imagine they would ever have been able to get from some kind of, commercial, mechanical Turk.
I wonder if they knew that when they launched it, if it was going to be like this. Maybe they had an idea.
It's from what I understand from, what I've read from sort of their internal discussions around this, that it was very divided about how the public would respond to this. I don't think that anybody expected it to be the level of, like it has become the cultural zeitgeist of the past 3 months. And no one really saw that coming in terms of this being the thing. But I want to get back to kind of what ChatGPT is, because I think it's important to kind of get all these pieces together, because it's not just the model. It's not just that layer of reinforcement learning. It's also that application experience wrapped around the top. So the fact that it is just, a web service that you go up to with just an internet connection, and you type in a question and you get an answer, initially it was, lickety split. Now, obviously there's different rates of response, but the fact that you are able to have this very smooth human-like interaction that is very disarming, I think is deeply, deeply compelling. And to me, that is what made, this take off to the degree that it did, was not just, having the model, because, we had the, several of the 3.5 series of models available through the OpenAI playground for several months before this. And, the reinforcement through human feedback layer, that had been coming along for a while, but, as an internal thing they were working on. But it was really when they wrapped this all together in an application that was a very compelling experience to everyone that this became, the phenomenon that it is now.
So the interface is really what broke it open.
it's the interface combined with the technology. It's the overall application experience. And I think that the reason I'm putting so much emphasis on that is because I think that also speaks to what is going to make the future of these technology experiences compelling, is when people build, full-bodied applications that have a reason to exist, that solve a problem, that meet a need that people had and weren't able to get met anywhere else. And I think one of the reasons that ChatGPT took off is because it met that need for so many different people, because it's a language model. And I think that's the big difference here is the language models, because they're trained on a broad set of language data, and because language itself is so flexible, that is what kind of allows them to be more
intuitive.
Not more intuitive, but I guess more flexible, I guess I'm going to use that word again, is the way to put it. Because, with most machine learning models, they're good for doing like one thing, predicting, whether a customer is going to churn, or identifying a particular image in a photo or something like that. Whereas these models can be applied to much more generalized tasks, at least in the realm of language, than most other models can be. Now, that can also be very deceptive, because they're really good at trying to predict, like I said, the next word in the sentence. When you start asking it things about, that involve, things like calculations or, complex questions, it will try to guess the next best word in the sentence based upon, the feedback that it's gotten in the past, its training data, not necessarily what is the most factual answer to that question. So that is what can lead to, some really off the rails answers that feel very, very assertive, because the model doesn't have any way of understanding when it's wrong. And that is one of the issues with these large language models, is they're very, very powerful, but currently there is not a good way to actually look inside of them and identify where particular facts are being derived from within their knowledge base, or even to go in and say, hey, that thing is wrong, don't respond with that fact again. And you can try and do that.
Well, isn't that what the reinforcement learning is for?
Yes. So you can do that with the reinforcement layer, but it can still lead to confusions. So in January, there was an issue where, and I don't know if this is still an issue because I've not gone back to ask it this question in a month or two, but it was responding to questions about Elon Musk saying that he was the CEO of Twitter and was also not the CEO of Twitter at the same time, because the training data goes up to the end of 2021,
right? Where
obviously he was not the CEO of Twitter. But then, 2022 happened, and somehow in that reinforcement data, it started to learn that Elon Musk was the CEO of Twitter, but that conflicted with part of the information in the underlying data set. So it came out with confused responses sometimes.
So yeah, I've been saying to people I've been chatting with about this, no pun intended, that it's not that, its data stops at 2021, but what I'm learning from you is because it's learning from us right now in real time, that's not the case.
Correct. Yes. And the reason that it's only trained up until the end of 2021, well, there's a couple of reasons, but one of the big reasons, and one of the reasons that would apply to other companies building their own model like this, is because it's so expensive to actually run the compute to actually train the model itself.
Yeah, we're going to get into that, because I saw an interview with Qualcomm CEO. It was very interesting. He's talking about these things running on smartphones.
Someday, maybe, but
he seemed pretty confident.
But
that's his job.
And there's a difference between training the models and running them for inferences. Those are two very distinct things. So,
all right. Well, we'll touch on that in a minute. So, but a large language model is what? It's just a form of AI, right? Can you kind of put that into context? What that
a large language model is a machine learning model that uses transformer networks to build its model. And essentially, generative pre-trained transformers, the GPT in ChatGPT, essentially are a way of doing deep learning that instead of, so in traditional deep learning, you have like multiple layers of quote unquote neurons that between each layer, you derive features from the underlying layer. So essentially, if you have like, a picture of a dog and you're trying to derive concepts from that, some of the features that you would derive might be, brown, or like, several twisted pixels next to each other. That would be like the curly dog hair or something like that. So you derive features that would identify that as a dog. So what a generative pre-trained transformer does is it looks at many of those features at once rather than just looking at a few of them or one of them. So it is able to have attention across many different features that allows it to have a much broader contextual understanding of the data that it's being trained on as compared to previous models. So that's essentially what it is overall. Is it's just a machine learning model that has been trained on this very, very large data set that is able to have a deeper semantic understanding across the data set itself.
Deeper semantic understanding faster, it sounds like, right? It sounds like the other models might get you there, but it might take a lot longer.
What do you mean by faster?
Well, I was thinking the comparison. So if it's looking at more than one aspect or attribute at a time, it's kind of running things in parallel, right?
Well, that's the training part. So when it's not, the parallelization doesn't necessarily matter for speed. It matters for what the end result model capability is. So the end results model has a greater understanding across all of these different domains than a single model would train in the traditional way.
For this call, that's plenty.
Okay.
I'm not going to dive any deeper because I can't. I don't know how. So I'm still a little want to go back to parameters because this term keeps popping up. And you see, you're equating that to neurons, but how does that relate back to these LLMs? Because I think there's this word parameter is starting to be used interchangeably with LLM in many ways, at least some of the stuff I'm seeing. So at least that's how I'm interpreting what I'm seeing. So
I had not heard these being used interchangeably. So parameters are an aspect of large language models. So you wouldn't like say, Rowan's brain weighs X number of pounds as a way of like referring to me. Like, so when we talk about the number of parameters, we are like broadly talking about the level of capability of the model. There's not like a linear relationship between the number of parameters and the level of performance of the model, but like generally you can kind of think about them being related. So the greater the number of parameters, the greater the performance of the model will be in terms of it being able to respond to queries more effectively.
Does it help at all to think of a parameter as a data point?
No, I think that would take people in the wrong direction if they thought of parameters as individual data points. Yeah. Because they're what is derived from the data points.
Interesting.
So like you wouldn't say like a neuron in your brain is like a data point about like, a car or a house.
Right.
It knows something about a car or a house.
It's an aspect of.
Yeah. Or
it
like
holds, so one neuron holds an aspect of that idea of a house. It's not contained in a single neuron. It requires multiple neurons to connect to create the image of a house or even the idea of a house.
Yes, right? This is a better way of thinking about it than the data points. Again, we're using metaphors, so not perfect.
Yeah,
I think that's a much better way of thinking about it than the data point. Yeah.
And so the way to interpret these models as they're being discussed is, the Megatron is, I think it was 500 plus billion parameters at the moment or something. This is from a month ago, a Stanford thing I was watching on YouTube.
Yeah, now, Megatron is quite large. I can't remember the number of parameters off the top of my head.
But it seems to be the measure that people are throwing around to give an idea of power, basically, or capability.
Yes, yeah. That is the general, like people are using it as a measure of capability, even though it's not like strictly one-to-one match of like, oh, we added 100% more parameters, we're 100% more effective. The gains are
interesting.
The gains are not marginal at this point, but they're less than like a one-to-one. increase.
Okay. So 100 billion parameters isn't necessarily more capable than, I don't know, pick a number, 100 million parameters.
Well, 100 billion parameters is not necessarily twice as effective as 50 billion parameters.
There you go. Thank you. That's what I was looking for. Okay. Because it's just too many moving parts in between, right? Okay. All right. So one of the comparisons I heard with ChatGPT is, especially when people try to convince you that it's sentient, is it's just, this is a very simplified explanation, but it's just really good at stringing words together.
Yes.
Right. I think it just doesn't do it justice. But at the end of the day, is that really what it's basically doing?
So as far as we can tell, yes. There is also a big and there as well. So so at their core, these things are n-gram generators. So they're just trying to guess what is the next most likely word in this sequence. But also, there is research going on into interrogating sort of what is going on inside of these models, because we really don't know, because neural networks are essentially a black box at this point in time. There's been lots of work to kind of like deconvolute them and things like that, but large language models, we don't know. But there has been some initial work in kind of trying to understand by observation what is happening inside these models. So there was a paper that came out last fall that looked at basically teaching, I can't remember what the base model was, but they taught it to observe Othello games to see whether it could infer what the next move should be.
And that's the game with the black white, you flip them over and try to get,
it's like Go, but a little bit different for anybody.
A simpler version, but
and what they found was that the model seemed to be building an internal representation of what the rules for Othello are without actually being told what the rules are, by only observing the games. So what they did was they basically showed it a bunch of games and then showed it games where illegal moves were played, and then asked it, or where the board setup was legal rather, and they asked it for what the next move was. And instead of just saying, oh, well, based upon the sequence of images, I assume the next one would be this, it actually took a move that was based upon, an internally constructed rule set based upon its previous observations. And so what was indicated from that initial study was that there is actually an internal world model within these language models that is constructed when you train them to build that world model, which implies that they could then be taught down the road to understand very complex processes and procedures eventually. So if, the model can understand like Othello and how it works and things like that, in addition to all its other capabilities, you can imagine that if you could then train it to say, understand, complex supply chain flows, or even, digital workflows, or fraud identification, or anything like that.
Chemistry.
Chemistry,
right.
yes.
Reactions, right?
Like cell biology, things like that. So down the road, this isn't something we can do with these large language models today, but the indicators are that down the road, we can really train them on very complex processes with just examples, and then ask them things about those processes.
Okay, let me stop here. I want to jump back to the Othello thing.
Yeah.
You said it learned from an illegal setup of the board. Is that?
It learned from legal rule setups, and then it was shown a regular game setup and an illegal game setup, and it was asked sort of what it was supposed to do.
Okay. And it did the right thing.
It did the right thing according to the rules. Essentially, it was given a choice, and it made the choice that demonstrated that it had an idea of what the rule set for Othello was, rather than just looking at a set of pictures and saying, what should the next picture be?
Okay. Oh, interesting. All right. And that's without ever being told what those rules
Correct.
were.
It learned from examples of previous game states. Yeah.
Okay. So how could that, that's the type of learning that could be applied in some of the things we just talked about, right? Understanding complex supply chains, making predictions that are based on, past learnings like we do as humans, right?
Yes. Yeah. And then you start to think about, this could go even farther now that we have kind of the glimmerings of multimodal large language models, which are large language models that don't just take text as input, and text as output, but can also use images, audio, and other types of content.
Oh, interesting. I never even thought about that. ChatGPT is only trained on text.
Well, so this is a very new thing. So there was a paper that was just published last Monday, I think, that was looking at these. And so this is still very cutting edge, but essentially you can interact. So exactly what you're saying. So think of ChatGPT, but you can give it an image of like, a photo you took of a pond and say, hey, like what species of bird are there on this pond and why do you think so? Or like, give it an image of like a particular car and say, hey, like, is there a dent on this? And getting answers like that. So
things that we take for granted as humans.
Yes.
Right. Because, you may hear a sound. Here's, you may smell in particular, right? I don't think you can train it on smell, but who the hell knows at this point, right? But, as a human, you smell something. That's one of the most powerful memory joggers. I don't know what the right word would be, but recall mechanisms for memory is smell. And so, and then hearing audibles, and then vision, I think, is even maybe third on that list. But smell in particular. And so if it's learning those associations, right, and it knows that a pond is typically a body of water that you find in a certain geographical location, it's going to have these types of this type of vegetation, therefore it's going to have this type of biosphere, which is going to support this level of higher of hunters, predators, which are birds, right? And so, but it has to make all of those leaps to get to the point where what kind of birds are going to be on this pond, right?
But also, well, no, it's that, and it's also able to look at the image and say, well, I see, there's a yellow beak that has, a black spot at the top of it, and then there's also, a red head crest.
Well, but see, I see you asking this question with just the image of the pond and no birds in sight.
Oh, so okay, so yeah, so I would say what birds would be on this pond?
Would be on this pond,
yes.
not what birds
so both
are.
Of those
because you can
things.
do that today with Google Lens. I can take a picture of a bird and it'll tell me what kind of bird it is. You know what I mean?
No, yes, I'm saying like both of these things. So like the multimodal nature of it to be more complex like that. So saying like, okay, so yes, both of those things. Yes, exactly. Yeah. And I think you make a great point that, and it's said in the abstract, one of the points of this paper is to kind of take language models outside of the prison of written language, because that is a very limited way of understanding the human experience.
Sure.
So I think that what you were just saying about, what happens when we're able to do it with smell? And I think we will be able to, fold in some type of olfactory data.
It's just molecules.
Yeah.
Ultimately, at the end of the day, being hitting receptors in your nose, and your brain interprets it as an orange or some, a leaf or whatever it is, right? Or,
exactly. And we already have things like, AlphaFold and things like that are, able to predict, protein shapes and whatnot. So I think, that in the next 5-10 years, maybe closer to the 5-year mark, that we will have multimodal language models that are maybe haptic, maybe olfactory, maybe auditory. Yes.
Now, how about motion capture on the physical body and the way physical bodies move, right? You can input that data.
Yes.
Right?
Yeah, absolutely.
And then you could watch someone walking down the street and do a gait analysis of somebody, something I have familiarity with. Yeah, and then make a prognosis. What is it when you go to the doctor?
Diagnosis
and make a diagnosis based on that, right? I mean, it's just kind of and again, I keep equating it back to how would I do it? How do I do it? Right? So when I see somebody walking by on a sunny day, I live on a busy street. People are constantly going for walks, and like I said, I have experience with gait analysis, and I can see people that have gait issues. Right now, I can't make that next leap into what's causing them, but but I know what I have that experience, and so having AI being able to do that in the context of the moment. So, is there ice on the sidewalk?
Well, yeah. So I think
are they running because it's raining? Well, that's going to be a completely different a scenario than are they just walking their dog, right?
Yes, and so I think what's important here is that say you did this professionally, like it was your job to analyze people's gaits walking down.
And there is. It's out there.
But say it was for you sitting in the window doing this.
Oh, right. Okay.
Your job. Yeah.
Taking notes. Got it.
So I think, so when we look at these models, it's not going to be that, we are just automating this analysis out there. It's going to be, the analysis happens with you sitting there as a human, and it says, okay, this person's walking, it looks like there's ice on the road and stuff like that. This is probably why they're walking the way they are.
Yeah, like shuffle dating or something.
Here's like all of the relevant research around people's gaits, at this temperature in this region at this time of year. And summarizing that for you so that you can use the AI to then make an informed decision. Because I think one of the very important things for all of us to keep in mind here is that, Kasparov beat Deep Blue in 99. But what are the top chess teams today? They are human computer hybrid teams. They're people working in combination with a supercomputer. So I think, that was one of the places where like, all right, well, computers have solved this, like it's a brute force problem. Like, why would we ever need humans in this ever again? But lo and behold, like a hybrid cybernetic environment is what is coming out with the best results. So I think as we look forward, to how these technologies develop and how we end up using them, I think it's very important to look at other technologies that we thought were going to operate wholly on their own, or would operate in a very automated way, that have turned out to be much more of partnership technologies for us.
Mm-hmm. Yeah, definitely. And that's a great segue into the next part of the conversation is what are the impacts, right? As a writer and a researcher and a podcaster, I was really quite taken aback by its ability to create content, what I've been doing for 20 plus years, and it could do it a lot faster than I can. But not necessarily better, that's subjective, but it was fast and it wasn't awful. And so that was a real eye opener. What do you think the impact of this stuff is? I think in the short term, it's a bit of a novelty. I mean, people are using it. I mean, there's Write Sonic, there's Jasper, at least on the content creation side. There's DALL-E, there's a bunch of these, there's a few others I've come across, I can't think of them right now, but that are generating images for people. And certainly in the creative space has caused quite a stir, right? But also in programming. I was talking to Forrester last year about a piece I was working on, and this idea of Turing bots came up, right? And they're like, well, in the piece, it was like, well, these are a ways off. Turing bot, for people who don't know, is machines writing code, right? So AI generated computer code. So, well, that's here. I mean, that's ChatGPT is a Turing bot. It's writing level 3. I think it passed Google's level 3 entry level programming.
Yep. Passed the test. Yeah. I think it's very important for us to remember when, ChatGPT is, acing these programming tests, that being a programmer is not the same as being a software developer. And so when we're thinking about, okay, if it could pass like Google, like this level of like software test, is it going to replace all the software developers? No, because it's not a software developer, because there's so many other things that go into the actual like process of software development. The explosion of capabilities around Turing bots, I think, it has really taken us a bit by surprise collectively, because, my colleagues have been looking at this space for several years, and Turing bots have been in place for several years, kind of developing along the lines of various techniques, using things like generative adversarial networks to create, test code and test data and stuff like that. But the ability to use large language models to generate code, to identify things like exploits and vulnerabilities, that I think is a very significant change here. And one of the things that we're very excited about
Wait, let me stop you for a second. To generate exploits and vulnerabilities?
To identify.
Thank you. Okay. But I mean, the same is true. The cyber guys are looking at this because they've been using automation for years to create code. So
and I was going to say there is a looming challenge to the security environment around the capability of these models to generate malicious code, as well as as good, clean code. So, on the positive side, we have, the ability for enterprises and any other type of company to basically use these tools to help their developers along, to say, have another place to go in addition to, your online web search or looking at Stack Overflow to get the piece of code that you need to complete that application or that query or whatever. But kind of looking down the road, this is, more of a way to kind of help upskill yourself as a developer. So, these are not going to replace writing applications whole cloth. They're going to help people write applications and kind of speed the process along. Particularly, I think they'll be very helpful for closing some of the skill gaps that are existent and growing around, particularly the security and enterprise integration space, where it's, very hard to bring together a lot of different enterprise large software systems, but also it's something you need to do. And same with the security space. So I think there's a lot of potential for Turing bots to help close the gaps around this, as well as also to, close the skill gaps, or close some of the skill gaps in the data science space as well, because you can also use these bots to generate models to do whatever other type of use case you have. So you could use ChatGPT to give you the framework to train a model to do revenue forecasting, for example, or something like that.
Mm-hmm. Yeah. Well, and we keep saying ChatGPT, but this is just generative AI.
Yes, correct.
Writ large that we're talking about. Yeah. Well, everyone's saying ChatGPT, so it's just kind of.
As I said to somebody else the other day, ChatGPT has very quickly become the Kleenex of this space.
Yeah, so, it's a new Xerox.
Especially with the release of the APIs for ChatGPT itself, and actually making itself a product that people can build off of. I think that's a gives it a little bit more staying power than just the consumer-facing application that we've had thus far.
Absolutely, and I've been using some of that stuff, and it's okay. It's okay. I mean, you gotta, and to your point about from the code side, on the content creation side, it's the same thing. I've been using this example of a small business, right? Let's take a pool company. And, the ability to create a blog using ChatGPT, and then they could generate this blog that they've been wanting to do, but can't afford because writers are expensive.
Yeah.
Marketing people are expensive, right? And so, and then they start getting some SEO out of it, and then on and on and on, right? And so when people do show up to their website to book a service, they see a whole litany of knowledge that this company has, and they feel better about working with them, and therefore they pick up 2 or 3 new customers a month.
I think the value for the small businesses there is not even, that it can just kind of automatically do it, but it can take, the owner who may not be a very good writer or
there you go,
whatnot,
right.
but
maybe very smart, but just
has
not very good
a lot of subject matter expertise.
Yeah, absolutely.
They can write out, 5 bullets about the most important thing about cleaning your pool in, the month of May or something like that.
Exactly.
And then give it to a large language model and have that turned into a blog.
Right.
So basically not asking the large language model to impart any new knowledge, but asking it to build upon the knowledge that you have or that the pool owner has, and to put that together in a meaningful way. I think that is one of the huge values here.
Absolutely. And that just, and the whole, how many developers jobs are open in this country right now? Just in this country, 500,000?
Something
million,
like that, I think, yeah.
I mean, worldwide, it's tens of millions of developers are in demand around the world. So if you're going to get rid of some of that grunt work, well, that's probably a net positive for just about everybody at the end of the day.
I mean, we've been going through what a now 60-year process of abstraction from the bare metal of computers, right? Like
ASCII code or whatever.
Yeah.
It is, right?
So we went from basics to COBOL to 2nd generation languages, 3rd and 4th. So every step in the software development world has been away from.
Interesting. I see where you're going.
Away from the basic complexity. We're introducing new complexities with analytics and stuff like that, but I don't think about, allocating, certain like bits of memory when I'm running any program, right? Like that is something that is abstract away from me. It's already handled. And so with, these Turing bots, that can be another step kind of along that way there. It's, not getting rid of this, but it's adding another layer of abstraction on top of it. And, it's similar to the way that we've had, low code interfaces. You could very easily see a tool that was set up where a business person comes in and says, I just type in, my requirements, and then it generates like a prototype that, isn't put into production, but then both the requirements and the prototype then goes to a developer. So the developer can say, all right, well, I can just start going from this framework and I don't have to kind of build it out myself. And this is a custom built framework to the requirements and not just like, a random template that I pulled down.
Right. Well, yeah, low code, no code, right? I mean, that's the other side of it, right? And the idea is to give, remember the citizen developer thing, to give business people the ability to improve workflows and business processes without having to learn how to code, nor burden IT with this thing, right? And as long as they're secure and they run through a few checks, but that's all super you can automate any of that stuff, right? I mean, that's really, that's just.
I wouldn't say automate. You can smooth it along significantly, but I hesitate for full automation on some of these things.
I just think on the DevOps side, you're running you're running security automation tools against your code to make sure it doesn't have glaring holes. That's what I mean.
Yes, when we get to that stage, yes, definitely automated. Agreed. Yeah, because I mean, when you're doing when I'm talking to folks about this, and they're like, oh, well, can we trust the code that's generated by this? I mean, can you trust the code that's generated by any developer? No, you can't trust the code that's generated by any developer. That's why we have QA. That's why we have testers. That's why we have, dev and test and prod and QA separate from test. Because we can't trust humans to do this. So why would we trust a machine to do this? So it's not about totally automating everything. It's about improving the overall way that we do these things. Right. And I think, that speaks to kind of the effect that it'll have on the job market overall. As with any kind of new technology, some jobs, will probably, be reduced and some eliminated. But on the other side, there'll be new jobs that are created as well. So these things are always tricky to navigate because it does cause real pain for real humans. And that is a real thing that sucks. So we have to be sensitive to that and empathetic to those people and help those people not get left behind. But also there are new opportunities that are being created that, we should be taken advantage of.
Right. I hear you. Yeah. Well, I want to take it back for a second. I was up a few minutes ago. There's a point I wanted to make because I think this is a great comparison to my buddy, Arthur Germain. He runs a small marketing shop on Long Island called Brand Telling. We were just talking today about ChatGPT, and he compared it to a really good research librarian. Right.
I think that is a good metaphor.
Me too. It's so they're not an expert in whatever you're looking in architecture or engineering, but they know how to help you get the things that you want quickly and help you speed your project along, whatever that is, right? And without them, it's almost impossible to look at the Library of Congress. You'd be dumbfounded. You wouldn't even know where to start. But you start by going to talk to that research librarian, right? And they know that library.
Yes, and particularly if we look at the Bing Chat implementation, I think this is a really good example of this because one of the things that ChatGPT itself, and I mean, large language models overall, is they're not able to cite facts like we were talking about before. But the Bing Chat implementation, it is using a combination of large language models and search to produce answers that are also cited back to the origin source of their information.
And that's really what ChatGPT itself is missing and what most people have cited as its biggest Achilles heel right now is there's no, like you said, you don't know where it's getting its information from and you can't look in the box to find out.
Yes, exactly. Yeah. Okay. And so once you start to get that attribution capability, that's when we really start to get to the research librarian level. Right. But even then, you can have incorrect results. So I've asked it, who is Rowan Curran? And the results that I've gotten back have combined multiple Twitter profiles that are not me, but but my name is just their Twitter profile, with my Twitter profile into a single answer. So even when there's attribution, you can still have some confusion in the answer, which is why I think if you're using these things to generate new knowledge or to cite facts, you really need to be able to drill back into it and say, where did this come from? Can I verify this and all that type of stuff?
So two questions before we go, because I know we're coming up on and thank you, we're going a little over. But first of all, do you think the hype is deserved? And then what's it going to do to SEO?
So I think that is the hype deserved? I think that the hype is a reflection of real world capabilities of this technology. And I think that it is going to continue to translate into really interesting and useful applications, and that we cannot even imagine what the applications that are built with this technology are going to be in even 3 years' time, I would say. I think that, does it meet the level of hype that it currently has? I think that depends upon who we're talking to, right? Like some people are saying, well, ChatGPT, the end of search, this completely changes the entire world overnight. Well, no, I don't think that that's the case, but is the world going to change in the next 2-3 years because of all this? I think so, absolutely. What does this do to SEO? I think that it continues to change SEO, and SEO has continued to evolve ever since, it was first developed. So if you roll back to when Google integrated BERT as part of their search solution in 2020, I think it was. So they integrate as part of how they produce results and summarize results.
I didn't know that. Okay.
Yeah. So there are blog posts from then about how to adapt your SEO to the newer setup of Google. So even back then, people were like, well, what is this going to do to SEO? How do we adapt this? It's just going to be another evolution. So if we take, the first iteration of this, and we'll see, what Google does with Bard and whatnot, but we'll take Bing Chat, for example. They integrate sponsored links and ads as part of like how search results appear in there. And it's essentially pulling back search results and synthesizing them for you. So if you're using if your search results already appeared at the top of Bing search results, they're going to be integrated as part of the Bing Chat results anyway, because it's looking at the top set of results. So what, is included in SEO and whatnot may change, but it's not like the end of SEO the same way it's not the end of search. It's just continuing to change the way the technology and people's approach to the technology operates.
Well, it might make it better. I mean, it might make for better content. I mean, SEO is search engine optimization, and people game SEO continuously to try to get on the first page of Google. Top 3 is really where you need to be for it to matter. And it's just a huge game. Right.
Well, so to that point, I think it might make the arms race around that like gaming of the system much more extreme, but I don't think that it is going to yeah.
I guess and I'm kind of speculating here, as we all are at the moment, but if the response you get is useful in its own right, then you're not clicking on anything. You know what I mean? And so that whole aspect of search goes away. You're getting a response that's useful. And then, you're not clicking through to the source material, which has all kinds of implications for publishers. But that seems to be the way it's going. That seems to be what it's going to look like in some form or other. And so, I don't know. I don't know. I don't know. Anyone has an answer at the moment until we start to see what these models look like from particularly Google, obviously, is the 8,000-pound gorilla of this question. So, but it's going to be an interesting ride, and things like you said, things are going to change a lot based on this. So.
Very, very much so. Yes, and it's one of these things. It's such an exciting space because so much is happening, but that also makes it extremely hard to predict what is going to happen outside of even 12, 18 months. I
mean, the curve is just exponential.
Yeah, and it's not just the curve, but there's so much active research in so many areas around the large language models, like whether it's, like we're talking about interrogating the inside of them, getting them to run more efficiently, like adding more data to them, applying them to specific situations.
Right.
Like any one of these areas could have significant progress that would advance the space in, X direction or Y direction. And, and who knows which of those it goes in. Yeah.
Right. Yeah. And who knows what advancement in each one of those areas is going to be adopted more wide scale and, on and on and on. Right.
Exactly.
And then you add, high speed networking to the mix, and now everything changes again.
Yeah.
Right.
Yeah.
So so one technology builds on another and it just reinforces.
And then you have network effects. Yes, absolutely.
Yeah. Network. Yeah. Exactly. Yeah. Okay. All right. Well, Rowan, thank you very much. Fascinating conversation. Hopefully we can have more of these in the future.
Yeah, this has been great. Thank you so much for having me on. This has been a really wonderful conversation.
If you like this episode, please tell your friends and subscribe. We post new episodes every week. If you'd like to join our mailing list, become a guest, or suggest topics for future episodes, you can find us on LinkedIn, on our landing page at anchor.fm/InsideDT or at InsideDT.net. Talk to you soon.